All right, welcome back. Today we're going to go over Amazon Athena. How do you query your data lake with SQL? But before we get there, hit the like button, subscribe, and share this with anyone you know who's taking the Amazon Associate Machine Learning exam. So imagine having terabytes of data sitting in S3 buckets and being able to query it instantly with familiar SQL commands. No servers to manage, no data to move, no complex setup. Amazon Athena makes this vision reality by functioning as a serverless SQL query engine that turns your S3 data lake into a queryable database. Boom. The power of schema. Okay. So Athena represents a fundamental shift from traditional database thinking. Instead of loading a data into a database and then querying it, Athena applies schemas when you read the data, leaving your original files untouched in S3. This is Schema-on-read. This approach means you can immediately start analyzing data regardless of its format: CSV, JSON, Parquet, ORC, Avro, even CloudTrail logs and VPC flow logs. The service runs entirely serverless, eliminating infrastructure management headaches. You simply point Athena at your S3 data, define how you want to interpret it, and start writing SQL queries. The underlying Presto engine, which is heavily evolved, right, handles the distributed querying process automatically. And Athena supports an impressive range of data formats, which you just talked about. The human readable ones like CSV, TSV, and JSON, they work perfectly for getting started. And then there's columnar formats like ORC and Parquet that provide significant performance benefits since Athena only scans the columns you're actually querying. And then Avro offers schema evolution capabilities and is splittable for parallel processing. All formats can be compressed using Snappy, zlib, LZO, or gzip compression to further optimize performance and reduce costs. Seamless integration with Glue. So Athena's true power emerges when combined with AWS Glue. This partnership creates a self-managed data catalog system that automatically discovers and structures your S3 data. The workflow starts with Glue crawlers scanning your S3 buckets, inferring schemas from the raw data, and populating the Glue data catalog with table definitions. Athena automatically detects these catalog entries and makes them available via querying tables, right? This integration works seamlessly. Any table definition in your Glue data catalog immediately becomes available in Athena for SQL queries. The beauty of the system extends beyond just Athena. The same Glue data catalog serves Redshift Spectrum for external table access, EMR for big data processing, and any tool compatible with Apache Hive metastores. This creates a unified metadata layer across your entire analytics ecosystem. So let's get started and show you. Let's go over here. All right. Let's go over here. Let's go to Athena serverless. All right. Okay, so let's go to Athena. Yeah. Should we do? Yeah, see, here's the pricing. SQLs per terabyte scan, $5 per terabyte. SQL queries, 30 seconds per TPU, DPU, 35 seconds per Apache Spark. All right, let's get this. Oh, wait. Query editor. Okay. Okay, so let's get data source. Oh, let me see. Okay, so it's already set up. Okay, so this is basically where you would get this. You would load an S3 bucket over here, right? And this is where you would configure where your query results location are, right? Oh, actually, this is where you choose your data set. Go over here, and you could do an outside account as well. And then the query, no, this would be query results and location. Yeah, that's right. Sorry. Okay, this would be the results. So we're going to save this. Query results encryption. It's not encrypted. Okay. And then choose the database. And there's data catalog. Okay, database. No. Okay. And then define, let me see, tables. Okay, so these tables are here. Okay, so what we can do is define them here and here. Okay, so let me copy this. Create external. table. If not exists, no, logs, empty string, comma, timestamp, string, comma, request, string. Okay. Oops. All right. Okay, let's run this. Let's see what we get. External, expecting materialize, multi. Oh, because it's damn it. Okay, let me see. It's because I have other stuff here already. No, I don't have. I don't. Okay, let me see. Da, 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 da. Hmm. So this is interesting. Let's clear this. All right. So I've not cleared this out from a previous use case. That's okay though. Yeah. Let me manage, clear this, save this, go back here. This is save, save queries, recent queries. Set up a query result location. I don't need to do that right now. Oops. Let's close this. Okay, we're going to stop with this right now and keep going with the rest of the general thrust of the lesson. All right, let's go to the cost model. Okay, so Athena's pricing model is elegantly simple for what we showed, $5 per terabyte of data scanned, rounded up to the nearest megabyte, and failed queries are free, and DDL operations like create and drop don't incur charges. The Glue data catalog provides the first million objects free, with S3 storage costs applying separately. The pay for scan model makes columnar formats like Parquet and Orc very valuable. Since Athena only scans the columns your query actually uses, these formats can reduce costs by 30 to 90% compared to row-based formats like CSV. The cost optimization becomes even more significant with compression. So Snappy, zlib, those compressions can further reduce the amount of data scanned. Okay. Advanced transformation. Okay. So you can keep going with the transformations, but we're going to stop going into Athena right now just because we don't have it configured correctly. But basically, you can do different transformations where you can use statements to make a tool for data transformation and optimization. So that's the create table as select, CTAS, right? This will allow you to create a new table from a query result while simultaneously converting formats, applying compression, and relocating data, right? So it effectively functions as an ETL job where you can filter, aggregate, join, transform data while optimizing its storage for future queries, right? So this capability makes Athena valuable, not just for analysis, but for data pipeline optimizations. All right, but performance. A couple of strategies improve Athena query performance and reduce costs. One, columnar formats, like we spoke about with Parquet and Orc. These should be your default choice for frequently queried data. They enable column pruning and predictable pushdown, scanning only the data your queries actually need. Two, data partitioning. This organizes your S3 data using logical directory structures like the year equals 2025, the month equals 09 for September, 10 for October, and the day would be a two-digit 15 or 01, depending on where it is. And so Athena can skip entire partitions when your queries include partition filters, reducing your scan volume. File consolidation, which matters significantly, right? Millions of tiny files create overhead that hurts performance. Aim for fewer, larger files, ideally 128 megabytes to 1 gigabyte each for optimal performance. When you add new partitions to existing tables, you can run repair commands to do that. And then that would be a repair table for your partition table and run it smoothly. Okay. security and access control. So Athena security operates through multiple layers. IAM policies control who can access Athena itself, with managed policies like Amazon Athena full access, right? That's the most broad access. You can have read-only as well. And you can have custom policies that enable fine-grained control. Data encryption options include SSE S3 for server-side S3 managed encryption, SSE KMS for server-side encryption with KMS customer master keys, and CSE KMS for client-side encryption with KMS. Workgroups. These can provide administrative control by separating users and applications, tracking costs per group, and enforcing query limits like maximum data scanned per query. This capability provides essential cost management and access control in multi-team environments. So you get that 2 for 1. Okay. ACID transactions. Okay. Athena supports ACID compliant tables using Apache Iceberg format. This brings transactional capabilities to your data lake. This advancement enables safe, concurrent operations, row-level isolation, and time travel capabilities for querying historical data states. Over time, Iceberg metadata can accumulate, so you need to optimize your tables periodically. All right. And machine learning. How does this work with machine learning workflows? So Athena integrates naturally into machine learning pipelines by providing SQL-based data exploration, feature engineering capabilities, and metadata cataloging that helps identify column types and ranges for machine learning models. You can easily retrieve historical time series data, aggregate features across large data sets, and convert data formats for optimal ingestion into SageMaker. The service connects to SageMaker Studio via JDBC drivers, QuickSight for visualization, and Data Wrangler for visual data preparation. The integration makes Athena a natural staging ground for machine learning data preparation workflows. And finally, how do you make the most of your data lake? So Athena transforms S3 from simple storage into an interactive, queryable data warehouse without the overhead of traditional database systems. The serverless model means you pay only for queries you run, while the integration with Glue provides automatic schema discovery that helps keep pace with your evolving data. For machine learning practitioners and data engineers, this combination creates a powerful foundation where you can store raw data cheaply in S3, let Glue discover and catalog schemas automatically, then use Athena to explore, validate, and prepare data for downstream analytics and machine learning workflows. The result is a flexible, cost-effective data lake that scales from gigabytes to petabytes while remaining queryable through familiar SQL interfaces. So that's our exposure to Athena. I want you to stick with us while we go into a little bit more AI managed services. But before you go, hit the like button, subscribe, and share this with anyone you know who's taking the AWS Machine Learning Associate exam. Thank you, and have a good day.